Welcome back. In the last clip we looked at the whole process of reading traces in to the platform and then saving them as a single project on your local machine to keep them all safe. And that saving the project is something that allows you to retain all the editing that you might need to do in the traces to get them to the point that you want. What we're going to do now is start exploring how the traces are processed so you can understand some of these metrics and what we need to do to get the data and check the data as we go through. When a trace is loaded into the machine, one of the web platform, one of the first things it does is work out what is a trace type. Trace types are either a bark to bark, B-B, or what we call a pith to bark, P-B. The difference between a bark to bark trace and a pith to bark trace is that in a bark to bark trace the software has been able to detect this flat line as the needle has come into the tree, through the cambium, through the wood, past the pith, out the exit radius, and then through the exit bark and out of the tree. If it can pick that flat line, then what it can do is look at the distance of the flat line from the 0 point, and that allows it to work out what sort of baseline correction it needs, or how much baseline correction it needs. So what this distance here, this y distance here on this scale, is that's the friction that is accumulated on the needle as it's drilled through the tree, so that it's actually got some residual resistance values resulting from friction on the needle. We assume that that's a linear function as it goes through from entering the tree right through to the exit. So we can apply a linear or baseline correction. I'll explain the whole non-linear baseline correction in a later video, but what we're doing here is we're seeing here at the entry side that the two traces are quite aligned, and they get more and more divergent as they go through until this exit is on the zeros line or this intercept line. Again, I'll explain these slopes and intercepts in more detail in a later video. If we can't pick up that flat line, we have a pith to bark trace. So if we look at a pith to bark trace, we can see that in this particular case, the trace has gone through the bark, into the wood, out the wood, into the bark, but it hasn't come all the way out of the bark. It hasn't been able to pick up that flat line. So we've got no confidence about what sort of baseline correction we apply. So what we've defined here is a baseline connection that's a generic connection that's applied to all pith to bark traces. And that's a correction that is based on the density of the wood and the length of the trace. And what controls this does seem to be somewhat species dependent. So that's where this select species comes in. We are dealing with radiata pine predominantly here in Australia, but we also have some southern pines. Southern pines seem to have greater resistance, and so this particular species selection will apply a slightly more severe baseline correction to that trace. In the data table down here, you can see that we record which species has been used and which baseline method has been used, so that you've always got a record of what particular parameters you've used in processing a particular trace to get these metrics. In a bark to bark trace, we have pith location. So once the trace has worked out the baseline correction, the processor then goes and works out where their cambial positions are, the underbark beginning and end. And it applies a pith location, which on a bark to bark trace is halfway between the entry and the exit cambium. On a pith to bark trace, it doesn't have a lot of confidence on where that entry cambium is, so that's an estimate. It works out based on the shape of the curve, has a go at putting the pith in the right location, This can be quite variable and difficult to do depending on where your trace stops. And then this exit cambium and this exit dBH is actually just a reflection of the entry portion. So it takes distance between the entry cambium and the pith and says that's where the exit. That's why that particular mark isn't on there. On a bark-to-bark trace, in this particular example, we can see we have got the flat line. It's been able to work out where the entry and exit cambiums are and applies a pith to bark. So one of the first things you want to do is step through and just check, because while it puts in the center, a tree is not always concentric or perfectly circular. So you just want to check. So you've got this option here to step through to change pith location. So this is a quick way of just saying, yes, I like the pith there. Click on that, or you can use the advance. This one is a pith to bark. It's going to be possibly a bit wobbly, so this one's not too bad. You can see here, this is also a pith to bark. It didn't come out. We're going to put the pith there, and it automatically advances to the next trace. This is a bark to bark. It's come in pretty central. And here you can see this is a bark to bark. Let's put it right in the middle between the two blue lines, but actually I'd say probably the pith is round about there. I'm looking for symmetry on either side, so you can sort of see that this is probably a bit of a bulb there, and that's probably a bulb there. So that little dip there is quite likely to be the pith. Now, because we're at the last of 5, it'll stop there. Update the table, and at this stage you want to just save your project again. Come back, just click on the previous one so that you don't keep saving multiple copies, although you can want. And we'll save that. And we've read the traces in, I've explained the baseline correction and done the first processing of this whole step through to change pith locations. So we'll stop there and go through the next video in looking at some of these buttons and what they do.